Hi, my name is Sean Phillips, and this is the final project for Team 20. Um, so, our research problem falls on the question: is energy efficiency consistent across all research buildings at the University of Cincinnati? For some background on this question, steam to heat the buildings is a really useful tool. Most of the buildings at UC use that as the main source of energy, especially in winter months, because it's the quickest and easiest way to heat a large area. So we have a lot of equal sized or nearly equal sized educational and research buildings on UC's campus. So our question mainly falls on does one use more energy or more steam than the other? And if they're on the same area, over the same area, then one or the other might have a higher energy efficiency. And what we want to look at is answer the question: is that consistent? Do the buildings have the consistent energy efficiency? And studies like this, if we find some sufficient evidence that shows that uh, there is consistency, UC can use this further in its campus planning and their building designs for the future. So the way we're going to do this is we have the steam usage data for both the Manti Center and the Kettering Lab complex from 2018 to 2021. We're going to take this data and we're going to make random samples of days in the winter months from the data for both of these buildings. And then we're going to be taking the random samples that we've created. We're going to find sample means, and then we can use hypothesis testing to come up with a comparative test to show the relationship between the two buildings and their energy usage. And then we can bring that back to show which building has, if there is a higher usage, and if not, if they're equal to each other, we can show that there is energy efficiency. There's consistency in the energy efficiency between the two buildings.
All right, I'm Tom Bush, and I'll be talking about data collection. Our random variable is going to be the daily steam sampled from the buildings, the Manti Center and the Kettering Lab. And the data we're going to be collecting are from the months of December to February in the years 2018 to 2021. So how we will be sampling the days, we assign numbers to each day in that period, and we pulled 40 numbers using a random number generator. So that is 40 days sampled, and we did not repeat any days. And we think the variable is appropriate because the steam usage is the raw data used to reflect energy used by each building. The data was collected from Khan, who is in this group. He co-opted at the UC Central Power Plant, so he has access to all the steam data from every UC building. And this data is very consistent, and they have records of it for each building, so that's how we can guarantee that our data is valid. Factors that could influence the data from each building include temperature in the class schedule, but we feel that the temperature factor we minimized by picking months in winter from December to February. And the class schedule should be consistent over the years through those months as well. And some assumptions that we need to make are that the buildings are roughly equal size, which is true for both the Manti Center and the Kettering building, and that the steam meters, which record the steam usage for each building, is accurate, and that steam is the main energy consumer in winter, which it is, and that data for both buildings is normally distributed. And we obviously feel that this data is appropriate because it is the raw data coming from the UC power plant. There's no way that we could fake this data. It's coming straight from the source, and it has been accurately recorded throughout the year. So we feel that the data is appropriate.
Hey, I'm Kanle. I'm going to be talking about the analysis and hypothesis testing for this data set. So right there is the summary for our data that we collect. So the Manti Center and Kettering Lab, the mean and the standard deviation. Note that this is the standard deviation for the sample and not the whole population. So no hypothesis is going to be that the mean usage for Manti Center and Kettering Lab would be the same. So their mu1 minus mu2 is going to be 0. And our alternative hypothesis is they're not going to be the same. So mu1 minus mu2 is not equal to 0. So that would be a two-tail for our test. So our test statistic is going to be a t-test or two sample because we do not have the population variance, and they would not necessarily be the same throughout the year. So this is a calculation for rejection region. So our degree of freedom was calculated to be 43. However, we will use degree of freedom as 40 because that's the closest that we have data on, and we think that is a sufficient approximation. So significant level is assumed to be 0.05. So split that into two, that would be 0.025, which from the t-test chart would give us a rejection region of either larger than 2.021 or less than negative 0.021. So computation give us a result of t equal to 1.1530. Since this t is not within the rejection region, we fail to reject the null hypothesis. In other words, we have evidence that we can support the null hypothesis.
The analysis I'm Mackenzie Howard. The analysis performed showed evidence that the Manti Center at the University of Cincinnati's main campus and the Kettering Lab at the medical campus has the same energy efficiency. These results show leaders at UC that their energy efficiency is consistent between two research buildings of approximately equal size. The validity is the results the study produced agreed with the null hypothesis, therefore validating the study. And the study is valid because the assumptions we made were true. The meters are reliable, the buildings are approximately the same size, the data is normally distributed, and steam is the main source of energy for the winter months. Future studies could be comparing other research buildings on University of Cincinnati's campus, comparing other sources of energy for each building, such as water, electricity, or natural gas, and gathering more reliable data and reperforming this study.